This lesson gives an overview of the 4 different methods for solving quadratic equations analytically. So far in this chapter, we've been looking mostly at quadratic functions and just writing them and representing them in different ways. The focus of this lesson is actually solving quadratic equations. So listed are 4 methods, using the zero product property, using square roots, completing the square, or the quadratic formula. Each method has its advantages and disadvantages, so we're going to look briefly at all of them. Okay, the zero product property is something we've actually used already in class. So let's just dive right into an example. Suppose you had the following: 3 times x minus 7 times x plus 2 equals 0. Well, first thing I'm going to do is divide both sides by 3. When I divide the left-hand side by 3, that factor of 3 disappears. And when I divide the right-hand side by 3, well, 0 divided by 3 is still 0. Now, as we've talked about in class, 0 is a very special number. If the product of two factors is 0, that means either the first one, in this case x minus 7 is 0, or the second one, in this case x plus 2, would have to be 0. If one or the other is not 0, then there's no way the product could be 0. And that leads us quickly to two solutions. X might be 7, or x might be negative 2. You may notice when you look at this particular solution that it's not incredibly versatile, meaning if it's not equal to 0, it's not going to work. And if it's not written out with factors, x minus 7, x plus 2 in this case, then it isn't going to work. So I usually try to use the zero product property if I can find a way of writing the function in factored form, because it's quick and easy. Unfortunately, it doesn't always work. So let's look at using square roots. Suppose you had the following equation: x squared equals 36. Well, I'm hoping that you can solve this one by inspection. You can just sort of think about what number you need to square to get 36. The technical process you might use is taking the square root of both sides, remembering that every number actually has two square roots, a positive one and a negative one. And the square root of x squared, well, that's just x, because squaring and square root undo one another. And the square root of 36 is 6. So you get two solutions, plus or minus 6. This method can be used for an equation that's a little bit more involved. For example, suppose you had 3y squared plus 2 equals 46. Well, I'm going to isolate y squared. So first thing I'm going to do is subtract 2 from each side, and I get 3y squared equals 44. Then I'm going to divide both sides by 3. Y squared equals 44 over 3. And then you might think, well, where do you go from there? We don't really know easily what the square root of 44 thirds is. Well, that's okay. We just write our solution like this: y equals plus or minus square root of 44 over 3. At this point, that's far enough, but I don't want to leave it like that in my video, so I'm going to go ahead and do a little bit of fancy square root manipulation on that one. What you're really supposed to do is break it into the square root of 44 over the square root of 3, and then the square root of 44 is 2 times the square root of 11 over the square root of 3, and then you're not supposed to leave a square root in the denominator. So if you multiplied by root 3 over root 3, you'd have 2 root 33 over 3. Alright, that was kind of tricky. Again, as far as I'm concerned at this point, you should follow me up until there, and the rest is gravy. If you understand that, that's great. Okay, we can also use square roots to solve problems that might not be so obvious how to do. So let's clear some space here, and let's look at an example that at first you might wonder what to do, but you'll follow, I'm sure. All right, so suppose you had the following: x minus 3 quantity squared equals 16. Well, I'm just going to go ahead and take the square root of both sides, remembering that when you do that, you need to introduce the plus or minus symbol on one side so that you don't lose the solution. And then because x minus 3 is squared, when you take its square root, you just get back to x minus 3. And square root of 16 is 4. And then to isolate x, I'm going to add 3 to both sides, and I get 3 plus or minus 4. And if you think about it, 3 minus 4 is negative 1. 3 plus 4 is 7. So you get those two solutions. Those are easy enough to plug back into the equation to see if they work. I'll leave that to you. All right, let's look at one similar idea, but maybe a little bit more involved. Okay, so suppose you had 3 times x plus 2 squared minus 7 equals, say, 14. So first thing I'm going to do is isolate the quantity that is squared. So I'm going to add 7 to both sides, and I get 21. Then I'm going to divide both sides by 3, and I'm going to get x plus 2 squared equals 7. Now I'm going to take the square root of both sides, remembering whenever I do that I need to introduce the plus or minus symbol. And then the square root of x plus 2 quantity squared is x plus 2. I don't really know the square root of 7, so I'm going to leave it like that. And then the final step would be to add negative 2 to both sides. And the standard way of writing a number that involves an integer and a square root is to put the square root at the end. So there's a quick solution to another square root problem. Now, again, this method only works if you have, well, let's circle it here, if you have something already written squared with the variable that you can isolate, and there's no other occurrences of the variable. That isn't going to work very often, so sometimes you might have to use the process called completing the square, which we've studied, to help you use the square root rule that was just demonstrated. So here's an example. Suppose you had x squared plus 6x equals 10. Well, you can isolate x squared, but then you have this x term that's going to mess things up. So what I'm going to do is complete the square on x squared plus 6x. So I take half of 6, which is 3, and 3 squared is 9. Now instead of subtracting 9 on the same side, I'll just go ahead and add a 9 on the other side as well. So I added 9 to both sides of the equation, and now since I've completed the square, I can write that as x plus 3 quantity squared equals 19. Take the square root of both sides, and I'm going to get x plus 3 equals plus or minus square root of 19. And then I move the 3 over by subtracting it, and I get my final solution, negative 3 plus or minus the square root of 19. So that means that if x is negative 3 minus the square root of 19, then I can plug it in for x up here and I'd get 10. And it should also work with negative 3 plus the square root of 19. Okay, the final method is the quadratic formula. We'll go over this in class tomorrow, and I'll show you how to use it. But the beauty of the quadratic formula is that it works for every quadratic equation. And the way it's derived is by starting with a general quadratic equation, ax squared plus bx plus c equals 0. Any quadratic equation could be written in that form. And then what we're going to do is complete the square, like we did on the previous screen, using, instead of numeric coefficients, using a, b, and c. It's somewhat lengthy, and I think it's a good thing for us to go over in class. So next time in class, I will derive the quadratic formula and show you how to use it. You've seen it before, When we're all done with the derivation, it's going to look like this. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. In Algebra 1 it was introduced, but you probably didn't know where it came from. In Algebra 2 you're going to learn where it comes from, and then you'll get a lot of practice using it. Okay, I don't really know if I've numbered this homework assignment correctly now that I'm looking at the screen, but for your next homework, 3 quadratic equations, you should be able to use each of the techniques demonstrated, except for the quadratic formula, on each of these. So see which technique goes with which problem, solve them, and have that ready for class next time.